How tough is this, do you think, for a theory of everything?
It has a kind of logical closure. It's so beautiful and so difficult to imagine changing in a consistent way that it becomes a final theory.
The question is, what mathematical tools you need to properly formulate the problem.
I mean, you can plug this into your computer, right? Go into Wolfram Alpha, type pi, parentheses, SINH, parentheses, type this in just like you see it, and put an X for anything you don't know how to type.
So there are non-trivial knots. I mean, like something like a trefoil knot. Is a trefoil knot a boundary of some very smooth, simple object in?
Right. So a trefoil knot will bound a punctured torus in force space.
So the figure eight knot hyperbolic volume.
Yeah, click on it, and then click on definition.
But that's the best you can do for a trefoil knot. It doesn't bound a disk.
Geometrically, we're talking about a closed boundary that's toroidal. It's the asymmetric Clifford torus. The internal construction of this balance also extends to set the possible tessellations of all the allowed 17 fundamental values of mass.
Where you're going to have a singularity of an algebraic variety in force space, and you look at what happens nearby, and the intersection with a small three-dimensional sphere near the singularity ends up being a knot.
Mirroring the division structure of the hyperbolic figure eight knot's internal complement volume, which is composed of 6 circles with an inside circle, so 7 circles in its most general decomposition. That construction on the inside, when you look closer, it's got this whole figure eight twisting in there.
And then the investigation begins.
Using this knot to bound, as the boundary of this thing in four-dimensional space, there's presumably an algebraic description of the surface there can be an algebraic description of the surface that you get in 4 dimensions.
What's that website again? wolframalpha.com. Free. It's like a calculator, but it does way more than a calculator. I really recommend spending time on it because it's a source in which you can ask questions that you have no idea what the answer is. No idea, but you know how to ask the question. Right? It starts telling you more things about the entire structure and so on.
You are going to make Professor Wolfram probably the happiest man in the world.